Hey guys, my name is Parth Patel, and this is my first lab, charged tapes in Physics 2. So a little introduction, objective slash purpose of this is basically perform an experiment with tape to see how they interact with each other if they're charged. And then we'll compare the calculations we get from that with a computer model, computational model, and we'll be using GlowScript for that to compute those values. So basically, some of the key physics topics we'll be using in this experiment would be Coulomb's law, which is over here on the left-hand side, and then Newton's second law, which is here on the right-hand side. So some assumptions and models that we'll be using in this experiment would be no air resistance. Each U-tape has the same charge, and we also treat that the tapes have a point charge. And additionally, with the point charges, they're located at the dead center of the tape. And then we're estimating the mass to be 1 gram per meter, which was converted to kilograms per meter later on when we were doing calculations. So these are the procedures to the tape. I won't waste your time reading through all of this, but basically we're having a base tape on a neutral surface and then making other tapes, U-tapes, that were placed on the base tapes and quickly taking them off without introducing a charge to them, and then see how they interact with each other, and then seeing how they interact with other charged items like plastic items. So the data values that I got were these. These were my data values for length, width, mass, and distance between the tapes that I got when I hold it together. Basically, I'm using packaging tape. That's why my width is a little bit bigger than normal, which is roughly 1.10 inches over the length is 8 inches. So yeah, that's why I have a larger width. And then on the right hand side, you can see the free body diagram, which basically has the yellow arrows representing the repulsive charges, the black arrow representing the normal force of me holding the tape, and then the blue arrow being the gravity constant that are felt by both of the tapes. So basically these were my calculations I did by hand, which first I started with Newton's second law to get Fg, which was 0.001991 newtons, which we assume static equilibrium here since the tapes weren't moving after they're being displaced the first amount. So I assume Fg equals Fe. And then doing some algebra with Coulomb's law, we figured out what the Q charge was, which is 1.1 times 10 to the negative 8 coulombs. And to get the deficient electrons is basically the charge over the how much electron is charged. So electrons are 1.6 times 10 to the negative 19th power. And basically to calculate the deficiency ratio with the atoms was first calculating the number of atoms, which was the surface area of the tape, which again for me was a higher surface area than most. Since my tapes were bigger, I used packaging tape. That was 9.929 times 10 to the negative 17 power. And then I divided both the electron deficiency over the atoms to get the ratio, which was 1.054 times 10 to the 7th power. This is basically my code. You can see on the left-hand side are the constants. These constants are basically the same constants that I had in my data values slide. And then on the right hand, I'm sorry, that was the left hand side. On my right hand side, you'll see the calculations, which were basically the same calculations I did by hand, but up here are all calculations, and then down here is just the visualization of the charges. And you can see that I have a scalar factor here that doesn't affect the math; it just affects how it looks on the picture, basically. So this is the output of the code. You can see how much bigger the spheres are versus the arrows. That's due to the scalar factor, and then this was the terminal command window, which you can see most of these numbers do line up with what I got by hand. But again, GlowScript keeps more terms, unlike me, which I truncated some values, and my calculator also truncated more values than normal. So these were some of the things I got to observe during the experiment and some errors that I thought that could happen during the experiment as well. So both U-tapes repelled each other. So both U-tapes were at least positively charged, in my opinion. The tapes were attracted to my hands, more specifically my index finger when I waved next to it. They were also attracted to neutrally charged objects like books, and then repelled anything that were positively charged like plastic pens. Some errors that could have happened during this experiment would have been me measuring the distance displaced between the two tapes. I could have been off by a little bit. I also could have touched the tapes when I was trying my best not to. I could have touched the tapes and gave it a charge. And my calculator could have truncated more of the values than the GlowScript model. So basically answering the discussion questions, what if the electrons had a positive charge and the protons had a negative charge? Basically being inverse. the observation would still be the same. They would still have a repelling force on each other. However, the direction of the forces would be flipped now on the y-axis. So the positive became negative, and the negative would have became positive. And why was it important for us to handle the charge shapes as low as possible? What would happen if the charge shapes did touch our hands or other objects? Basically, we'll be transferring charges to the tapes if we did touch it with our hands or with other objects. So we're trying to touch as low as possible during the experiment to reduce the number of charges that we're transferring to it.